is called a plug-and-chug density problem. It says 0.711 grams of CO2 is in a container at 0.421 atmospheres and 298 Kelvin. What is the density of this gas in grams per milliliter? Now you have to remember that density is equal to mass per volume. You can see that with the units that they've told us to give them density in, which is grams, which is a unit of mass, over milliliters, which is a unit of volume. Now, we're given a mass, right here, 0.711 grams of CO2. So that mass is taken care of. But what about the volume? Nowhere in this equation does it mention, nowhere in this problem does it mention the volume. Well, the good news is we have this, the ideal gas equation. With this, we can solve for the volume. As you can see, we have the pressure, which is given to us in the problem, the moles, which we can get from the grams of CO2, and the molar mass of CO2. R is the universal gas constant, and we know what the value of that is, and T, which is given to us as 298 Kelvin. So, just to remember, so we know what to write down correctly in our problem, P is equal to 0.421 atmospheres. V, well, we don't know what V is yet. N, we know how to find moles by dividing 0.711 grams of CO2 by the molar mass of CO2, which is 44.0 grams per mole. And that equals 0.0161 moles of CO2. R equals 0.0821 liters, atmospheres, mole, Kelvin, and T, which was given to us, is 298 Kelvin. Okay, so before we start plugging everything in, let's algebraically solve with the variables shown in this equation for what we want, which is V. So, PV equals nRT, V equals nRT over P. Now all we have to do is substitute everything that we wrote up here. So, this equals 0.0161, which is moles of CO2, times 0.0821, which is the universal gas constant, 298, which is the temperature, and we divide that all by the pressure, which is 0.421 atmospheres. And so our final answer we get for V is 0.939 liters. Now that's a good answer, but you can see up here that we want our answer in grams per milliliter, so we better convert this into milliliters by multiplying by 1,000. So now we have 939 milliliters. Now our final step for this density problem, I'm just going to rewrite what we had above. Density is equal to mass over volume. Well, we have a mass, we have a volume, so now we just have to plug into this equation. So, our mass is 0.711 grams divided by our volume, which is 939 milliliters, and that overall gives us our density of 7.57 times 10 to the negative 4 grams per milliliter. And the reason this is called a plug and chug is because all you're doing is plugging in all the values into this equation, getting a value, and then replugging it in here. So that's the plug and chug density problem.